We sleep soundly at night because we believe the universe is a rational, orderly machine governed by unbreakable laws. We trust that gravity will always hold us down, that entropy will march forward, and that the past cannot be older than the beginning. But astronomers have found a specific coordinate in the sky, where that trust has been violently shattered by a single object. It is a faint high-velocity subgiant that sits in the constellation of Libra, hiding in plain sight among the darkness. To the naked eye, it looks like nothing, just another flicker of ancient light traversing the void of the cosmos. But when we pointed our most sensitive instruments at it, the data that came back terrified the scientific community. The numbers suggested a mathematical impossibility, a paradox so severe it threatens to unravel the standard model of cosmology. This star, designated HD 140283, appears to possess an age that simply should not be possible in our reality. We call it the Methuselah star, named after the biblical figure who lived longer than any other human being. But this celestial object isn't just old. It is ancient in a way that defies the logic of time itself. According to our best measurements of the cosmic microwave background, our universe is exactly 13.8 billion years old. That is the hard limit, the absolute beginning of everything, the moment the clock of existence started ticking. Yet, the initial calculations for the Methuselah star indicated it was roughly 16 billion years old. Do you understand the implication of that number? It is a child that was born before its mother existed. If the data is correct, this star was burning hydrogen in a void that had not yet been created. It suggests that our timeline is wrong, or worse, that the laws of physics are not constant across the universe. Scientists scrambled to find an error in the math, desperate to prove that this star wasn't breaking reality. They adjusted for oxygen abundance, they recalculated the distance using the Hubble Space Telescope, and they prayed for a glitch. But even after the most rigorous corrections, the star refused to fit comfortably within the age of the universe. The margin of error allows for a slim possibility of conformity, but the tension remains dangerously high. This creates a cosmic crime scene where the suspect is time itself, and the evidence doesn't make any sense. If this star is truly older than the universe, then the Big Bang might not be the beginning we thought it was. It opens the door to terrifying theories about what came before, and what might still be lurking from that pre-universe era. Imagine an object from a previous cycle of existence surviving the death of its own universe to haunt ours. The Methuselah star is speeding through our galaxy at 800,000 miles per hour, as if it is running from something. Its composition is metal poor, a ghost from an era when the universe was pure hydrogen and helium. Every other star we see is polluted with heavier elements, the ashes of dead stars that came before them. But Methuselah is pristine, a fossil that has somehow survived for eons without evolving or dying. The existence of this star forces us to ask a question that makes astronomers lose sleep at night. Is our measurement of the universe's age fundamentally flawed, or is something wrong with the star itself? The Hubble Space Telescope spent hours staring at this anomaly, trying to unlock the secrets of its birth. We looked at its parallax, its luminosity, and its chemical spectrum, hoping to find a mistake in our tools. Instead, we found that the star is rapidly exhausting its core hydrogen, nearing the end of its impossibly long life. When it finally dies, it will take the secrets of the pre-universe with it into the black void. But it is not just the age that scares us. It is what the age implies about the expansion of space. If the universe is younger than we think, then the expansion rate is faster, and the end is coming sooner. We are trapped in a discrepancy called the Hubble tension, and this star is right at the center of the conflict. Two different methods of measuring the universe's age are giving us two different answers, and they cannot both be right. One method looks at the early universe, and the other looks at stars like Methuselah in the modern universe. The gap between these two numbers represents a hole in our understanding of reality big enough to swallow a galaxy. We are standing on the edge of a precipice, realizing that the ground beneath our feet might be an illusion. If we cannot explain how this star exists, then we do not truly understand how the universe began. Perhaps the Big Bang was not the beginning, but merely a transition from a previous state we cannot comprehend. The Methuselah star stands as a silent witness to a time that our physics says should not exist. It mocks our certainty, shining brightly with a light that traveled through a history we have not yet written. We are about to embark on an investigation into the dark heart of this cosmic paradox. We will tear apart the standard model and look at the terrifying alternatives that this star forces us to consider. Because if the laws of physics are broken here in our own galaxy, then they can be broken anywhere. And if the laws can be broken, then we are not safe in the orderly universe we thought we inhabited. Let us look closely at HD 140,283, the star that is older than the universe itself. To understand why this star is a terrifying anomaly, we must first establish the rigid cage of time in which we are all trapped. The universe is not infinite in its duration. It has a birth certificate, a specific moment when the lights were turned on. For decades, the European Space Agency's Planck satellite scanned the cosmic microwave background, the fading heat signature of the Big Bang itself, to determine the precise age of our reality. The data was exhaustive, the math was checked by thousands of physicists, and the verdict was unanimous. The universe is 13.8 billion years old. This is not a rough estimate. It is the fundamental constant upon which all modern cosmology is built. It acts as an absolute wall. Nothing in existence can be older than 13.8 billion years, because before that moment, there was no time, no space, and no matter. To find an object older than this limit is akin to finding a man who claims to be older than his own grandmother. It suggests that our fundamental understanding of the linear progression of time is either flawed or completely shattered. Stars are the clocks of the cosmos, and we know how to read them by analyzing the ashes they leave behind. When the universe began, it was a pristine ocean of hydrogen and helium, with no heavy metals to weigh it down. The first generation of stars, known as population 3 stars, were massive, short-lived monsters composed entirely of these light elements. When they exploded in violent supernovae, they forged heavier elements, carbon, oxygen, and iron, scattering them into the void to be recycled into the next generation of stars. This means that the more metal a star contains, the younger it is. It is polluted by the corpses of its ancestors. Our Sun, for example, is rich in iron, marking it as a relatively young star. But when astronomers analyzed the spectral signature of HD 140283, they found almost no iron at all. Its metal content is less than 1% of our Sun's, indicating that it formed from a primordial gas cloud that was almost entirely pure. It is a relic from an era that borders on the mythical, a time when the universe was dark, cold, and empty. The terror set in when the initial calculations regarding the star's age were finalized in the early 2000s. Based on its luminosity, its surface temperature, and its chemical composition, the models churned out a number that made no sense: 16 billion years. The scientists checked the code, reran the simulations, and questioned the calibration of their instruments. But the number refused to budge. A 16-billion-year-old star residing in a 13.8 billion-year-old universe is a logical paradox that suggests the standard model of physics. The theory that describes every particle and force in the universe is fundamentally broken. It was as if we had found a dinosaur bone buried in a layer of rock that dated back to before the Earth was formed. The implication was stark. Either the star is defying the laws of stellar evolution, or the universe is much, much older than the Planck data allows. If the latter is true, then everything we know about the Big Bang, the expansion of space, and the ultimate fate of humanity is based on a lie. Faced with this existential contradiction, the scientific community launched a desperate investigation to fix the age of the Methuselah star. The primary suspect was the distance measurement. In astronomy, if you don't know exactly how far away a star is, you cannot accurately judge its true brightness, and therefore you cannot calculate its true age. In 2013, a team of astronomers led by Howard Bond secured time on the Hubble Space Telescope, the most precise eye humanity has ever built. They utilized the fine guidance sensors to measure the star's parallax, the tiny apparent shift in position as the Earth orbits the Sun, to triangulate its exact distance from us. They treated the star like a rogue agent, subjecting it to the most rigorous surveillance possible, hoping that a more accurate distance measurement would lower its luminosity and, consequently, its age. They were looking for a mathematical loophole that would allow them to save the standard model from total collapse. The Hubble data came back, and it did provide a correction. But it was not the salvation the physicists had hoped for. The new, precise distance measurement adjusted the star's luminosity, bringing the calculated age down from the impossible 16 billion years to a slightly less impossible 14.46 billion years. While this was a significant reduction, the problem remained glaringly obvious. 14.46 billion is still greater than 13.8 billion. The star was still older than the universe that contained it. It was like adjusting a timeline and realizing the crime still took place before the suspect was born. The investigation had tightened the net, removing the variables of distance and brightness errors, yet the anomaly persisted. The Methuselah star refused to conform. It stood defiant against the math, a glowing sphere of plasma that seemed to mock our attempts to categorize it within our limited understanding of temporal mechanics. At this point, the scientists had to rely on the concept of uncertainty to sleep at night. In every scientific measurement, there is a margin of error, a fuzziness in the data where the truth hides. For the refined age of 14.46 billion years, the uncertainty was calculated to be plus or minus 800 million years. This created a sliver of hope, a desperate overlap on the Venn diagram of reality. If we assume the star is at the very lower limit of its age range, roughly 13.6 billion years, and the universe is at the absolute upper limit of its age range, 13.8 billion years, they can theoretically coexist. But this solution is terrifying in its fragility. It requires us to assume that every single variable is pushing to the extreme edge of probability just to keep our laws of physics intact. It is a God of the gaps argument, where we hide our ignorance in the statistical noise, praying that better data doesn't widen the gap again. However, the mystery of HD 140,283 digs deeper than just a simple miscalculation of years. It exposes the oxygen catastrophe. To verify the age, astronomers looked at the oxygen-to-iron ratio within the star. Oxygen is produced relatively quickly in the universe by massive stars exploding, while iron builds up slowly over billions of years. A high oxygen-to-iron ratio confirms the star was born very early, shortly after the first supernovae began to pollute the cosmos. The Methuselah star has an oxygen abundance that is higher than expected for its iron levels, which actually argues that the star formed later than its iron content suggests, yet its luminosity argues it is older. These contradictory biological markers of the star are like finding a human body that has the bone density of a child, but the cellular decay of a centenarian. The clues do not line up. The star is sending mixed signals that confuse our standard models of stellar evolution, suggesting that the early universe was a chaotic, unpredictable place where the rules of star formation were different than they are today. The implications of this star extend beyond its own solar system. They strike at the heart of the Hubble tension, the greatest crisis in modern cosmology. We currently have two ways to measure how fast the universe is expanding. One method uses the cosmic microwave background, the baby picture of the universe, and the other uses standard candles, like pulsating stars and supernovae in the local universe. Ideally, these two methods should give the same number for the expansion rate, known as the Hubble constant. They don't. The early universe method suggests a slower expansion, implying an older universe. The local universe method suggests a faster expansion, implying a younger universe. If the local measurements are correct, the universe might actually be closer to 12.8 billion years old, not 13.8. If that is true, then the Methuselah star is not just slightly older than the universe, it is billions of years older, a paradox so massive it would require us to rewrite every physics textbook ever written. We are left with a disturbing realization. The Methuselah star might be the ghost in the machine that proves our simulation of reality is glitching. Some theoretical physicists have proposed that the universe did not start from a singularity, but rather from a big bounce, a cyclic model, where our universe is just the latest iteration in an infinite chain of expanding and contracting cosmos. In this terrifying scenario, is it possible that HD 140,283 is a survivor? Could a low-mass star, through some freak of gravitational shielding or spatial anomaly, survive the collapse of the previous universe and be ejected into ours? While standard physics says no, the math of the star's age whispers, maybe. It would explain why it looks so old. It literally carries the entropy of a dead universe within its core. It is a scavenger of time, living on borrowed energy from a reality that ceased to exist eons ago. Let us look deeper into the mechanics of this impossible object. HD 140,283 is a subgiant, which means it has exhausted the hydrogen in its core and is beginning to evolve into a red giant. This specific phase of life is crucial for dating because it is the turning point where a star's brightness changes predictably. Astronomers use this turning point like a stopwatch, but the tick rate of this stopwatch depends heavily on how opaque the star's plasma is. If the plasma is more opaque, radiation takes longer to escape, and the star evolves differently. The opacity depends on the elements present. By tweaking the theoretical opacity of the star's interior, scientists can force the age down. But this feels like cheating. It is adjusting the evidence to fit the verdict. We are manipulating the laws of thermodynamics in our simulations just to make this star stop breaking the rules. It reveals a deep confirmation bias in science. We are terrified of anomalies that we cannot explain. But what if the problem isn't the star? What if the problem is dark energy? We assume that dark energy, the mysterious force accelerating the expansion of the universe, has been constant throughout time. This is the cosmological constant introduced by Einstein. But if dark energy is dynamic, if it changes strength over time, then our calculation of the universe's age could be wildly off. A phantom dark energy that was stronger in the past would mean the universe expanded faster initially, making it much younger than we think. In this scenario, the Methuselah star is telling the truth, and the universe is the liar. The star is a rigid anchor of reality, exposing the fact that the fabric of space-time is far more malleable and unstable than we are comfortable admitting. We are drifting in a sea of changing physics, and this star is the only lighthouse showing us the rocks. There is another, darker possibility that comes from the realm of modified gravity. The theory of general relativity has passed every test in the solar system, but on galactic scales, things get messy. We invented dark matter to explain why galaxies spin so fast, effectively adding invisible mass to make the equations balance. But what if dark matter doesn't exist? What if gravity itself behaves differently at low accelerations? If we are using the wrong theory of gravity to model the evolution of the universe, then our timeline of 13.8 billion years is a fiction. The Methuselah star might be normal age in a universe that is governed by modified Newtonian dynamics, or some other exotic gravity theory. This star is a rebel, refusing to follow the gravitational dictate of Einstein, hinting that our most celebrated genius might have missed a piece of the puzzle. As we stare at HD 140,283, we must also consider the anthropic principle in its most horrific form. The principle states that we observe the universe the way it is because if it were different, we wouldn't be here to observe it. But this star challenges the stability required for life. If the fundamental constants of the universe can fluctuate enough to allow for a star older than the cosmos, then they can fluctuate enough to destroy us in an instant. Vacuum decay is a theory suggesting our universe is in a, quote, false vacuum, a semi-stable state. If a quantum tunnel event were to occur, a bubble of true vacuum could expand at the speed of light, deleting physics as we know it. Anomalies like the Methuselah star are like cracks in the windshield of reality. They might be harmless cosmetic flaws, or they might be the stress fractures warning us that the entire glass is about to shatter. The investigation into HD 140,283 also forces us to confront the limitations of human perception. We rely on light to measure the universe. Light is our messenger, carrying information across the void. But light is subject to interference. Dust, magnetic fields, and gravitational lensing can all distort the message. While we believe we have accounted for the reddening caused by interstellar dust between us and the Methuselah star, there is always the fear of the unknown unknown. Could there be a cloud of invisible, exotic matter drifting between Earth and Libra that is warping the light in a way we haven't discovered yet? We are like prisoners in a cave, interpreting shadows on the wall, claiming we understand the object casting them. This star is a shadow that doesn't look like the puppet, and it scares us because it suggests the puppet master is playing a different game. Let's pivot to the star's trajectory. HD 140,283 is not just sitting still. It is a high-velocity star, plunging through the galactic disk at over 800,000 miles per hour. This speed indicates that it didn't form where we see it today. It is a traveler, likely born in a dwarf galaxy that was cannibalized by the Milky Way billions of years ago. Our galaxy is a graveyard of smaller galaxies, ripped apart by tidal forces. Methuselah is a refugee from one of these destroyed worlds. By studying it, we are performing an autopsy on a galaxy that no longer exists. Its extreme age might be typical for the dwarf galaxy it came from, suggesting that pockets of the universe evolved at different rates. This shatters the principle of cosmological isotropy, the idea that the universe is the same in all directions. If different regions have different histories, then there is no single age of the universe. The existence of this star also throws a wrench into our understanding of the dark ages of the cosmos. After the Big Bang, the universe was hot and opaque. As it expanded, it cooled, entering a period of darkness before the first stars ignited to reionize the gas. This is the epoch of reionization. If Methuselah is truly 14.5 billion years old, it implies that star formation began almost immediately, or perhaps even during the initial expansion. This contradicts the cooling models required for gas to collapse into stars. It suggests that the early universe was far more efficient at creating monsters than our simulations allow. It paints a picture of a violent, rapid birth of the cosmos rather than the slow, gradual awakening we teach in universities. It means the universe woke up screaming, instantly birthing stars like HD 140,283 in a frenzy of creation that we cannot replicate in our supercomputers. There is a psychological element to this mystery as well. Why are we so desperate to prove the star is wrong? It is because humans crave order. We built the standard model of cosmology to replace the chaos of ancient mythology with a rational framework. But when a single point of data defies that framework, we feel a primal anxiety. We call it statistical outlier or measurement error to sanitize the threat. But nature does not care about our models. HD 140,283 exists. It is burning fuel right now, indifferent to our confusion. It is a physical object that refutes our mental map of the territory. The map is not the territory. The map says, "Here be dragons at the edge of time," and this star is the dragon flying back into the known world to set our theories on fire. Furthermore, the chemical composition of the star provides a window into the nucleosynthesis of the Big Bang itself. We predict exactly how much hydrogen, helium, and lithium should have been produced in the first 3 minutes of the universe. This is BBN, Big Bang nucleosynthesis. The lithium levels in old stars like Methuselah notoriously do not match the BBN predictions. This is the cosmological lithium problem. HD 140,283 has far less lithium than the Big Bang should have provided. Where did it go? Did the star destroy it? Or was the Big Bang different than we thought? Maybe the initial explosion produced different ratios of elements because the fundamental forces were acting differently. If the recipe of the primordial soup was different, then the entire timeline of cosmic evolution is suspect. The star is a sample of that soup, and it tastes wrong. We must also consider the role of stellar diffusion. Over billions of years, heavier elements in a star can sink away from the surface towards the core due to gravity, while lighter elements float up. This settling process makes the star's surface appear more metal-poor than it actually is, which tricks us into thinking the star is older. Scientists have tried to model this diffusion to correct the age of HD 140,283. It is a complex game of fluid dynamics inside a nuclear furnace. When they apply maximum diffusion corrections, they can shave off another few hundred million years. But this feels like desperation. We are inventing invisible internal processes that we cannot observe, simply to force the star to comply with the 13.8 billion year limit. It is the scientific equivalent of gaslighting the data. You aren't that old, we tell the star. You just look old because your iron sank. But the star offers no confirmation, only its silent, ancient light. Let us zoom out to the ultimate existential horror, the scale of our ignorance. We estimate that we know what 5% of the universe is made of, baryonic matter. The other 95% is dark matter and dark energy. Substances we have never touched, seen, or created in a lab. We only know they exist because of their gravitational effects. To claim we know the precise age of the universe to within 1% accuracy, while admitting we don't know what 95% of the universe is is the height of arrogance. The Methuselah star is the penalty for that arrogance. It is a reminder that our laws of physics are merely local ordinances of physics. In the deep time of the early universe, or in the vast distances of the void, the rules might change. We are trying to measure a chaotic, dark ocean using a ruler made of sugar, and we are surprised when it dissolves. Consider the distance again. 190 light-years. In cosmic terms, HD 140,283 is right next door. It is in our backyard. This isn't a fuzzy blob seen by the James Webb telescope at the edge of the visible universe. This is a neighbor. If we cannot explain the age of a star that is practically touching us, how can we possibly trust our measurements of galaxies billions of light-years away? The proximity of the anomaly makes it more damning. It implies that the anomalies are not rare, they are just usually too far away to be scrutinized this closely. If we could see every star in the universe with the clarity we see Methuselah, we might find that the impossible is actually the normal, and that our model of the universe is the aberration. We might be the ones living in a bubble of false logic. The story of this star is also a story of technological evolution. In the 1950s, we thought the universe was 2 billion years old. Then 10 billion, then 20 billion, then back to 13.8. The number fluctuates as our eyes get sharper. HD 140,283 has been watched by every generation of telescope. It has seen our understanding of the cosmos expand and contract like a breathing lung. It has outlived every theory we have ever proposed. There is a melancholy to this. We are ephemeral creatures of carbon and water, lasting less than a century, trying to judge the age of a nuclear fire that has burned for 14 billion years. We are pointing our fingers at eternity and demanding it show us its ID. The star's persistence is a testament to the endurance of matter against the eroding force of entropy. If we accept the possibility that the universe is older than 13.8 billion years to accommodate this star, we run into the Fermi paradox. If the universe is older, then life has had even more time to arise. If stars like Methuselah formed 14.5 billion years ago, they could have harbored planets. Civilizations could have risen and fallen billions of years before the Earth was even dust. The silence of the night sky becomes heavier. Where are they? If the timeline is longer, the galaxy should be teeming with ancient gods. The fact that we see nothing but dead stars and silence suggests that either we are the first, or that civilizations inevitably destroy themselves quickly. The Methuselah star might have shone down on dead empires that we will never know, its photons hitting the ruins of worlds that have been ground to dust by the turning of the cosmic wheel. Let's delve into the specific mechanics of the main sequence turnoff. This is the method used to date the star. Stars spend most of their lives fusing hydrogen. When they run out, they turn off the main sequence and expand. The mass of the star determines exactly when this happens. Higher mass stars burn fast, lower mass stars burn slow. HD 140,283 has a very specific mass, roughly 0.8 times the Sun. Based on our nuclear physics, a star of this mass should take a specific amount of time to reach the subgiant phase. The fact that it is already there is what dictates the 14+ billion year age. To make it younger, we would need to prove that it has more mass than it appears to. But mass is hard to hide. Gravity doesn't lie. Unless the star is shedding mass in a way we don't see, a stellar wind that is invisible to our sensors, the clock is accurate. The timer has rung. There is a theory called vacuum energy relating to the expansion of the universe. It suggests that empty space has energy. This energy drives the expansion. If the nature of vacuum energy has evolved, then the clocks of the universe, the expansion rate, and the clocks of the stars, nuclear fusion, might have become desynchronized. Imagine a movie where the video runs at one speed and the audio at another. The Methuselah star is the audio track that doesn't match the video of the Big Bang. We are watching a dubbed reality. The law of physics we are breaking might be the assumption that time flows at a uniform rate for all processes. Perhaps gravitational time dilation on a cosmic scale played a role in the early universe, allowing the star to age faster than the universe around it, relative to our observation point. As we investigate further, we must look at the fine-tuning of the universe. The laws of physics seem perfectly tuned for stars to exist. If the strong nuclear force were slightly weaker, hydrogen would not fuse into helium and stars wouldn't shine. If it were stronger, all hydrogen would have fused instantly in the Big Bang, leaving no fuel for stars. HD 140,283 sits on this razor's edge. Its existence proves that the fine-tuning held true even in the earliest, most chaotic moments of reality. But its extreme age challenges the timeline of when that tuning settled into place. If the laws of physics were cooling and settling like molten glass after the Big Bang, this star suggests they solidified much faster than our theories predict. It is a relic of the cooling phase of the laws of nature themselves. The scientific community is currently hoping for data from the James Webb Space Telescope, JWST, and the upcoming Gaia mission data releases to solve this. Gaia is mapping the positions of billions of stars with unprecedented accuracy. If Gaia reveals that HD 140,283 is actually closer than Hubble thought, the luminosity drops, the age drops, and the crisis is averted. But initial Gaia data has supported the Hubble distance. The star is not backing down. It is holding its ground against the best technology the 21st century can throw at it. It is almost as if the universe is taunting us, presenting a puzzle piece that is clearly from a different puzzle, daring us to force it in. What if the Big Bang was not the beginning of time, but the beginning of space? Time could be an emergent property that behaves differently under extreme entropy. In the heat death of the universe, time essentially stops because nothing changes. In the early universe, where change was rapid, did time flow differently? The Methuselah star might be a chronometer that measured dense time differently than we measure diluted time today. We measure time by the oscillation of cesium atoms. But 14 billion years ago, the density of the universe was different. If time is relative to gravity and velocity, and the entire universe was a dense, high-velocity object, then years might not mean what we think they mean. The star is a victim of relativistic effects on a cosmic scale. The problem of HD 140,283 is effectively a crisis of cosmology. It is cited in papers discussing the need for new physics. This is a euphemism for "we were wrong." New physics implies particles we haven't found, forces we haven't felt, and dimensions we haven't entered. The star is the gatekeeper to this new realm. To explain it, we might need to invoke axions, sterile neutrinos, or primordial black holes. We are layering complexity upon complexity to avoid the simple, terrifying truth. The universe is not a clean mathematical equation. It is a messy, biological, evolving entity that makes mistakes. And this star is a scar tissue from a wound in the early cosmos that never quite healed correctly. We have to consider the look-back time. When we look at the star, we see it as it is now, or 190 years ago. But its chemical composition tells the story of its birth. It is a time capsule. Opening this time capsule has released a virus of doubt into the scientific community. It challenges the Lambda CDM model, the standard model of Big Bang cosmology. Lambda represents dark energy. CDM represents cold, dark matter. This model has been the king for 20 years. HD 140,283 is the assassin in the throne room. Along with the Hubble tension, it is chipping away at the foundation of the king. We are witnessing the slow death of a scientific paradigm, killed by a single, faint subgiant in the constellation of Libra. Let's address the concept of primordial heavier elements. Standard theory says the Big Bang made only H, He, and Li. But what if there were trace amounts of other elements produced in exotic processes we don't understand? If HD 140,283 had a tiny bit of extra carbon or oxygen to start with, not from dead stars, but from the Big Bang itself, then our age calculations are wrong. But proposing that the Big Bang made carbon is heresy. It violates the known laws of nuclear physics. Yet, here we are. We must choose between two heresies. Either the Big Bang created heavy metals, or the star is older than the universe. Both options are terrifying, because they mean we fundamentally misunderstand the origin event of our existence. The visual appearance of the star is underwhelming. It is a 7th magnitude star. You need binoculars to see it. It is not a blazing quasar or a terrifying black hole. It is humble. This adds to the eeriness. The destroyer of cosmology is a quiet, unassuming neighbor. It reminds us of the banality of evil concept, but applied to physics, the banality of anomaly. The thing that breaks reality isn't a giant monster. It's a small, misplaced number in a spreadsheet. It is a glitch in the code. And like any glitch, it suggests the system is artificial, or at least imperfectly designed. As we look at the future of this star, we know it is dying. It will eventually expand into a red giant, swallowing any planets it might have. None have been found, but it's possible. And then collapse into a white dwarf. When it becomes a white dwarf, it will simply cool for the rest of eternity. It will become a black dwarf trillions of years from now. It has seen the beginning of the universe, and it will see the end. It is the ultimate witness. If stars could think, what memories would this one possess? It remembers a time before the Milky Way existed. It remembers the darkness before the galaxies lit up. It is the elder of the tribe, and we are the children trying to tell it that it doesn't exist. The tension between observation and theory is the engine of science. But usually observation wins. If you see a white crow, the theory that all crows are black is dead. HD 140283 is the white crow. Yet physicists are refusing to let the theory die. They are fighting to paint the crow black. They are adjusting the age, tweaking the error bars, invoking diffusion and distance corrections. They are struggling to save the Big Bang timeline because the alternative is chaos. If we admit we don't know the age of the universe, we lose our creation myth. Science is the modern mythology, the story we tell ourselves to feel safe. This star is punching a hole in the storybook. Let's revisit the error bars one last time. 14.46 billion plus or minus 0.8 billion. The lower limit is 13.66 billion. The age of the universe is 13.8 billion. The overlap is a mere 140 million years. That is the breathing room for modern physics. 140 million years out of 14 billion. That is a 1% margin of safety. We are hanging by a thread. If the star is just 1% older than the lower limit, or the universe is 1% younger than the upper limit, the thread snaps. We are betting the entire house of physics on this 1% overlap. It is a precarious position to be in. It feels less like science and more like gambling. There is a connection here to the crisis of the 20th century, the ultraviolet catastrophe, which led to the discovery of quantum mechanics. Classical physics predicted infinite energy from a black body, which was impossible. That anomaly birthed a new physics. HD 140,283 might be the ultraviolet catastrophe of the 21st century. It is the anomaly that cannot be explained by relativity or the standard model. It is beckoning us to invent the next layer of physics. Perhaps a theory of quantum gravity will explain how time dilates in the early universe, reconciling the star's age. We are on the verge of a paradigm shift, and this star is the catalyst. Imagine the universe as a growing organism. The Methuselah star is a cell that has refused to divide, refused to evolve, retaining the DNA of the zygote. By sequencing this cell, we are trying to understand the conception of the organism. But the DNA is garbled. It contains codes that shouldn't be there. It suggests the organism has a genetic disease, a fundamental flaw in its structure that might eventually kill it. This flaw is the inconsistency of time. If time is not absolute, if it stretches and compresses in ways we can't map, then history is a hallucination. We must also talk about the cosmic variance. This is the idea that our location in the universe is special or unique, skewing our data. We assume we are in a typical region of space. But what if we are in a void, a region of low density? If we are in a local void, matter creates less drag on expansion, making the local universe look like it's expanding faster. This would mess up our age calculations. If we are living in a cosmic backwater, a hole in the Swiss cheese of the universe, then our measurements of H0, Hubble constant, are biased. Methuselah might be a normal star, and we are the weird ones, living in a distorted bubble of empty space that warps our perception of time. The star's orbit is also highly elliptical. It dives through the galactic plane and shoots out into the halo. This plunging orbit subjects it to varying gravitational potentials. Could the passage through dense regions of the galaxy have affected its evolution? Unlikely. Stars are robust. But it adds to the narrative of the outsider. It does not move with the herd. The Sun and the other stars circle the galactic center in an orderly disk. Methuselah cuts across the traffic, a reckless driver on the cosmic highway, ignoring the lanes, ignoring the speed limits, ignoring the laws. To summarize the investigation so far, we have a suspect, HD 140283. We have a crime, existing before the universe began. We have the forensics, Hubble, Gaia, spectroscopy. We have the alibi, error bars overlapping by 1%. The jury is currently deadlocked. Half the physicists say, it's just measurement error, calm down. The other half say, this is the smoking gun for new physics. The public looks on, unaware that the sky is harboring a paradox. We continue to circle the star, gathering more data, hoping for a confession. But the star remains silent. What if the universe has no beginning? The Big Bang Theory implies a t=0. But some theories, like eternal inflation, suggest that universes are popping into existence like bubbles in a boiling pot of water constantly. In a multiverse scenario, time is infinite. Our 13.8 billion years is just the age of our bubble. Is it possible that matter can leak between bubbles? Could HD 140283 be a piece of debris from a collision between our universe and another? It sounds like science fiction, but the math of string theory allows for brain collisions. If this star is an intruder from another dimension or another bubble universe, then its age is perfectly explainable. It is an immigrant from a much older reality. The terror of the Methuselah star is the terror of the uncanny valley. It looks like a star, acts like a star, but it feels wrong. It violates our intuition. It reminds us that the universe is not built for us. It is not built to be understood by ape descendants with telescopes. It is a wild, untamable thing. We build cages of logic, mathematics, physics, philosophy to try and contain it. But every now and then, the beast sticks a claw through the bars. This star is the claw. It scratches at our ego, reminding us that we are small and our knowledge is fragile. Let us look at the lithium depletion again. Lithium is fragile. It is destroyed in the cores of stars. The fact that Methuselah has low lithium is expected, but the amount of depletion is the key. The models of internal mixing, how the star churns its plasma, are complex. We might be underestimating how efficient the star is at destroying lithium. If we fix the mixing models, maybe we fix the age. But every fix creates a new problem. If we make mixing more efficient to explain the lithium, we change the core temperature, which changes the luminosity, which changes the age, but not always in the direction we want. It is a Rubik's Cube where fixing one side scrambles the other. The star forces us to confront the limit of knowledge. Is there a wall where science stops? Can we ever truly know the age of something that existed before recorded history? We are deducing the past from the present. It is like trying to reconstruct a burnt-down house from a pile of ash. We are good at it, but are we perfect? HD 140283 suggests we missed a spot. There is a beam in the ashes that isn't burnt. It stands upright, defying the fire. This star is that beam. It refuses to fit the narrative of the fire. There is a beauty in this broken law. If the universe was perfectly understood, it would be boring. The anomalies are where the discovery happens. This star is a gift. It is a treasure map marked with an X. Dig here, it says. Dig here to find the next theory of relativity. Dig here to find the truth about dark energy. We should not fear the Methuselah star. We should revere it. It is the most important object in the sky because it is the one that proves we have more to learn. It is the frontier. But the frontier is dangerous. The answer to the riddle might not be what we want. What if the answer is that the universe is decaying faster than we thought? What if the age is correct, but the end is closer? If time is non-linear, an old star might indicate that we are approaching the asymptotes of existence. The Big Rip, where the expansion of the universe tears atoms apart, might be calculated based on the age of the universe. If the age is wrong, the countdown clock to the Big Rip is wrong. We might have less time than we think. As we enter the final phase of our investigation, we must look at the star's isolation. It is alone. Most stars are in clusters or binary systems. Methuselah is a solo traveler. This isolation has protected it. It hasn't interacted with other stars that could strip its mass or pollute its atmosphere. It has remained pure. This purity is what makes it such a good test subject. It is a control group of one, a single, perfect sample of the ancient universe, preserved in the vacuum of space waiting for us to find it. We are currently upgrading our models of stellar opacity. This is the measure of how light travels through the star. New data from atomic physics experiments on Earth, smashing atoms in colliders, is updating our opacity tables. These tables are used to calculate the age of stars. It is a beautiful connection. Smashing atoms in a tunnel in Switzerland might solve the mystery of a star 190 light-years away. The micro and the macro are connected. If the opacity tables change, the age of Methuselah changes. We are waiting for the lab results to save the cosmos. But until those results come in, the paradox stands. 14.5 billion greater than 13.8 billion. The inequality is a scar on the face of science. It generates headlines, it fuels conspiracy theories, and it keeps astronomers employed. It is the, quote, perfect storm of a scientific mystery. It has high stakes, the age of the universe, a clear suspect, HD 140283, and no conviction. It is the ultimate cold case. And, like all cold cases, it haunts the detectives who can't solve it. So we watch the star. We track its path through the dark. We analyze every photon it emits. We run our simulations until the silicon chips burn hot. We are looking for the mistake. But deep down, a part of us wonders, what if there is no mistake? What if the star is right? What if the universe is stranger, older, and more terrifying than we ever dared to imagine? What if, when we look at HD 140283, we are looking at the face of God, and He is laughing at our attempts to measure Him with a ruler? To truly grasp the horror of HD 140283, we must return to the cosmic microwave background, CMB. This is the baby picture of the universe, taken 380,000 years after the Big Bang. It shows a universe that is almost perfectly smooth, a sea of plasma with only tiny ripples of density. These ripples are the seeds of galaxies. The problem is that the smoothness of the early universe fights against the rapid formation of stars like Methuselah. To get a star to collapse from a gas cloud so quickly, you need gravity to overcome pressure. In the chaotic, hot, expanding soup of the early cosmos, this should have been incredibly difficult. The existence of a star this old implies that gravity was acting more efficiently than our models predict. It suggests that the clumping of matter happened violently and instantly rather than gradually. It hints that the early universe was not a smooth sea, but a turbulent storm of gravitational anomalies that we cannot see in the CMB data. We are missing a chapter of history between the Big Bang and the first light, and in that lost chapter, monsters were born. There is a theory that attempts to bridge this gap, but it requires us to abandon the idea of a single Big Bang. It is called conformal cyclic cosmology, CCC, championed by the Nobel laureate Roger Penrose. In this terrifying model, our Big Bang was not the beginning of everything, but merely the death of the previous universe. The universe goes through infinite cycles, or eons. It expands until all matter decays into radiation, losing all scale, and then resets into a new Big Bang. In this framework, is it possible that information, or even matter, could survive the transition? Could HD 140,283 be a fossil that washed up on the shore of our universe from the ocean of the previous one? Penrose suggests that gravitational waves from massive black hole collisions in the previous eon could leave scars on our CMB. If a physical object, a compact stellar core, somehow surfed the wave of the transition, it would appear to be impossibly old because it literally is. It carries the chronometric data of a dead reality. While the idea of a star surviving a Big Bang sounds like madness, the alternative, that the star formed 400 million years after the Big Bang but looks like it's 14.5 billion years old, requires us to break the laws of nuclear physics. We have to choose which law we want to break, the law of cosmic origins or the law of stellar fusion. Most scientists prefer to break the fusion models because they are messy and complex. They argue that turbulence inside the star is mixing the fuel in a way we don't understand, making it look older. But this is a black box argument. We can't see inside the star. We are blaming the invisible machinery of the star's core to save the visible machinery of the universe's timeline. It is an act of faith. We are praying that the error lies in the opacity tables of hydrogen plasma, rather than in the fundamental nature of time itself. But the star shines on, indifferent to our prayers, glowing with the light of a paradox that refuses to be solved by tweaking a spreadsheet. Let us consider the, quote, fine structure constant, often denoted by the Greek letter alpha. This number, roughly 1/137th, determines the strength of the electromagnetic interaction. It dictates how electrons bind to atoms and how light interacts with matter. If alpha were slightly different in the early universe, the rate of nuclear fusion would have been different. A different fusion rate would change how quickly a star burns its fuel. If the Methuselah star formed in an epoch where alpha was slightly lower, it would burn hydrogen more slowly, potentially tricking us into thinking it is older than it is. But this solution is a poison pill. If the fundamental constants of nature can change over time, then physics is not universal, it is local and temporal. It means that the laws of reality are slippery, evolving things. If alpha changes, then molecular bonds change. Biology becomes unstable. The stability of the universe we rely on for life is an illusion, a temporary plateau in a shifting landscape of changing constants. This brings us to the variable speed of light, VSL theories. Einstein postulated that the speed of light, c, is constant in a vacuum. It is the cosmic speed limit, but some cosmologists have proposed that light traveled much faster in the early universe to solve the horizon problem, the question of why the universe is the same temperature everywhere. If light was faster back then, it also affects how we date stars. A higher speed of light in the past would alter the energy output of early stars. HD 140,283 might be a relic from the fast light era. But if light speed decays over time, it implies that the universe is slowing down in a fundamental way. It suggests that the processor speed of reality is throttling down. We might be living in a universe that is freezing not just in temperature but in causality. The Methuselah star, with its ancient light, might be a remnant of a high-bandwidth universe that no longer exists. We must also examine the tip of the red giant branch, TRGB. This is a specific moment in a star's life when the helium core reaches a critical temperature and ignites in a helium flash. The brightness of the star at this exact moment is a standard candle used to measure distances. The age of HD 140,283 depends heavily on where it sits relative to this evolutionary point. If our theoretical calculation of the helium flash luminosity is off by even a fraction, the age estimates swing wildly. Recent studies using neutrino cooling rates suggest that the helium flash might happen later than we thought. Neutrinos are ghost particles that escape the star's core instantly, carrying away energy. If HD 140,283 is producing more neutrinos than standard models predict, perhaps due to exotic particle interactions, it would cool the core, delaying the helium flash and making the star look older. The star might be a particle physics laboratory, revealing the existence of axions or sterile neutrinos that we cannot detect on Earth. The axion hypothesis is particularly chilling. Axions are hypothetical elementary particles that are strong candidates for dark matter. If they exist, they would be produced in the hot cores of stars. They would fly out of the star without interacting, stealing energy. This axion cooling would force the star to burn its fuel faster to maintain equilibrium. A star that burns faster dies younger but looks evolved. Wait, if axions cause the star to burn faster, it would look older than it really is for its mass. This is a potential solution. If the universe is filled with an axion field, HD 140,283 might be a victim of this dark matter wind, aging prematurely. It would mean the star isn't chronologically old, but biologically old. A 13-billion-year-old star with the body of a 16-billion-year-old. It implies that dark matter isn't just a gravitational glue, it is a parasite, sucking the life out of stars and accelerating the entropy of the universe. But what if the error is in the main sequence turnoff fitting? This method relies on fitting a curve to the star's color and magnitude. It is an exercise in statistical matching. We have libraries of isochrones, theoretical lines that show what stars of a certain age should look like. We try to pin the tail on the donkey. But what if our library is incomplete? The isochrones are generated by computer codes like MESA or YREC. These codes are written by humans. They contain assumptions about mixing length theory, convective overshoot, and radiative levitation. These are approximations of fluid dynamics. We are trying to model a chaotic three-dimensional nuclear inferno using one-dimensional mathematical shortcuts. The crisis of the Methuselah star might simply be the crisis of the one-dimensional approximation. We are arrogant enough to think we can simulate a star on a laptop, and when reality disagrees with the laptop, we question reality. Let's zoom out to the environment again. The Milky Way halo. This is the spherical cloud of old stars and dark matter surrounding the spiral disk. HD 140,283 is a halo star passing through the neighborhood. The halo is the attic of the galaxy, where the dusty, forgotten things live. The conditions in the halo are different from the disk. The density of gas is lower. The radiation field is different. Has the star spent its entire life in this cryogenic freezer? If the environment of the halo suppresses stellar aging processes, perhaps by shielding the star from cosmic rays or tidal forces, then our calibration based on disk stars is wrong. We assume all stars age at the same rate regardless of location. But if environment dictates evolution, then time is not the only variable. Geography matters. The star is a stranger from a bad neighborhood, and we are misjudging it by the standards of our safe, suburban solar system. The concept of stellar cannibalism must also be ruled out. Sometimes, a star looks young because it ate a neighbor and gained fresh fuel, a blue straggler. But HD 140,283 looks old. Could the opposite happen? Could a star be stripped of its outer layers by a companion, making the core look more exposed and evolved? This is the stripped subgiant scenario. However, we see no companion. We see no signal of a binary partner in the radial velocity data. If there was a partner, it is gone. Did it explode? Did it get flung away? Or was it never there? The solitude of the Methuselah star is its strongest alibi against interaction theories. It stands alone, unmarred by the violence of a partner. It is a monk, meditating in the void for 14.5 billion years, untouched by the chaos of relationships. This isolation forces us to accept its internal properties as intrinsic, not extrinsic. There is a psychological phenomenon known as the streetlight effect. A drunk man looks for his keys under the streetlight not because he lost them there, but because that's where the light is. We study HD 140,283 because it is bright and close. It is under the streetlight. But because it is an anomaly, we obsess over it. What if the universe is full of 16 billion-year-old stars, but they are all dim red dwarfs that we can't date accurately? What if the impossible is actually the average, and the possible stars like our sun are the weird ones? We define normal based on the sample size of stars we can easily measure. This selection bias might be hiding a universe that is vastly different from our models. The Methuselah star might be the only honest witness in a galaxy of liars, and we are trying to silence it because its truth is inconvenient for our textbooks. We must return to the Hubble tension, because it is the context in which this mystery breathes. The discrepancy in the expansion rate, 67 kilometers per second / MPCVS 73 kilometers per second MPC, changes the age of the universe from 13.8 billion to roughly 12.8 billion. If the 73 number is right, the local measurement, then the Methuselah star is not just 0.7 billion years too old. It is nearly 2 billion years too old. That is not a gap. That is a canyon. It would imply that the star existed for 2 billion years before the universe began. This is a logical absurdity of the highest order. It forces us to consider tired light theories, where photons lose energy as they travel, mimicking expansion. It forces us to reconsider the Doppler shift. It forces us to look at the foundations of astrophysics and ask, is the house built on sand? The star is the tide coming in, washing away the sand. Let's explore the dark energy equation of state, denoted as W. In the standard model, W equals -1. This means dark energy is constant. But if W less than -1, we have phantom energy. In a phantom energy universe, the expansion accelerates so fast that it eventually rips apart galaxies, stars, and atoms. This is the Big Rip. If W is not -1, the age of the universe changes. If we tweak W to make the universe older, to fit the star, we might inadvertently create a universe that ends in a Big Rip sooner. By saving the past, we might be dooming the future. The equations are connected. You cannot simply make the universe older without consequences. The Methuselah star is forcing us to turn the dials on the control panel of the cosmos, but we don't know what the other dials do. We are playing with the settings of reality to accommodate one stubborn star. Consider the lithium plateau again. This is the Spite Plateau, named after the astronomers who discovered it. Old halo stars all seem to have the same amount of lithium, which is lower than the Big Bang prediction. For years, we thought this was the primordial level, but if HD 140,283 has depleted its lithium, maybe all stars have. If all stars destroy lithium, then the Spite Plateau is a graveyard of element 3. It means we have no pristine sample of the Big Bang. We are looking at a crime scene that has been cleaned up. The evidence has been tampered with by the stars themselves. If we can't trust the lithium, can we trust the helium? Can we trust the metallicity measurements? The star is an unreliable narrator. It tells a story of the early universe, but it has edited the manuscript over 14 billion years of nuclear burning. We are trying to read the original text through layers of redaction. The 3D non-LTE, non-local thermodynamic equilibrium models are the bleeding edge of this research. Standard models assume LTE, that atoms and radiation are in balance locally. But in the outer atmosphere of a giant star, density is low and radiation dominates. The balance is broken. When scientists apply non-LTE corrections to HD 140,283, the iron abundance changes. The star becomes metal-richer, which makes it younger. This is the current best hope for solving the crisis. It is a technical fix. We are saying, the star isn't breaking physics. Our assumption of thermodynamic equilibrium was just lazy. But even with non-LTE, the error bars are uncomfortably tight. We are scraping the barrel of physics to find a few million years here and there. It feels like accounting fraud, shifting losses to different quarters to make the balance sheet look solvent. What about gravity waves? The early universe was likely ringing like a bell with gravitational waves from inflation. Could these waves have created high-density pockets that collapsed into stars before the general gas cooling phase? This would be a primordial star formation mode that is distinct from the population 3 model. If HD 140,283 is a result of a gravitational collapse shortcut, it explains why it formed so early. It didn't wait for the gas to cool. It was crushed into existence by the trembling of space-time itself. It would be a star born of pure force, not just thermal evolution. A force star. It changes the narrative from a gentle coalescence to a violent, pressurized birth in the Dark Ages. Let's consider the observer's timeline. We measure time based on the Earth's orbit. A year is a local concept. We extrapolate this to the cosmos using the speed of light. But general relativity teaches us that time is malleable. Clocks run slower in strong gravitational fields. If the early universe was denser, did cosmic time flow at a different rate relative to quantum time? The age of the universe is calculated in co-moving coordinates, but the star lives in proper time. Is there a drift between these two clocks over 14 billion years? A discrepancy of just 5% would solve the mystery. But questioning the synchronization of cosmic clocks is a heresy that undermines the entire metric of the Big Bang. It suggests that 13.8 billion years is just a coordinate number, not an experiential reality. There is also the void theory. We might be living in a giant cosmic void. The KBC void, Keenan, Barger, Cowie. If the Milky Way is inside a bubble of underdensity roughly 2 billion light-years across, it distorts our view of the outside universe. It affects the Hubble constant measurements. It makes the universe look younger than it is. If we correct for the void, the universe might be 15 billion years old. Then HD 140,283 fits perfectly. The crisis is just a side effect of our bad real estate. We are living in a hole, and we are confused because the light from the outside looks weird. The void solution is elegant because it saves the star and the Big Bang, but it requires us to accept that we are in a special, unique place in the universe, which violates the Copernican principle: we are not special. We must choose. Are we special, or is physics broken? The Copernican principle states that the Earth is not in a central, specially favored position. Science hates special explanations. But the Methuselah star is forcing us to look at special cases. Maybe the star is special. Maybe our location is special. Maybe the early universe was special. The more we investigate, the more we have to invoke special pleading. This is the hallmark of a theory in decline. When you have to make up a new excuse for every anomaly, your core theory is rotting. The Ptolemaic system, Earth-centered universe, added epicycles to explain planetary motion. HD 140283 is the epicycle of the Big Bang theory. We are adding loops to the math to keep the Earth and the Big Bang at the center of the narrative. The star also challenges our definition of metallicity. We use HH, iron to hydrogen ratio, as a clock. But what if the first supernovae were inefficient? What if they ejected mass in a way that didn't mix well? You could have pockets of gas that remained pristine for billions of years, forming young stars that look old, metal poor, or pockets that got polluted instantly, forming old stars that look young. The mixing of the galactic soup might be clumpy. HD 140,283 might be a late bloomer that formed from a pocket of gas that was miraculously unpolluted, a bubble of the Big Bang preserved in amber. But the probability of such a gas cloud surviving for billions of years without collapsing or being polluted is statistically zero. The clumpy universe defense is weak. Let's talk about the beryllium clue. Beryllium is another element used to date stars. It is created by cosmic ray spallation, cosmic rays hitting atoms. It acts as a secondary clock. Measurements of beryllium in HD 140,283 have been attempted to cross-check the age. The results? Ambiguous. The data is noisy. The star guards its secrets well. It is as if every time we find a new key, the lock changes shape. This resistance to interrogation is uncanny. It feels like the universe is enforcing a censorship on the past. The cosmic censorship hypothesis usually applies to singularities, preventing us from seeing naked infinities. Maybe there is a temporal censorship that prevents us from seeing the exact moment of creation. The star is the blurred line where the censorship begins. The philosophical weight of this star cannot be overstated. It represents the unknowable. Science is built on the premise that the universe is knowable, that if we have enough data and enough computing power, we can solve any equation. HD 140,283 is the counterargument. It suggests that there are limits to reconstruction, that entropy destroys information irretrievably. We might never know the true age of this star because the information required to calculate it was lost in the chaotic turbulence of the pre-galactic era. We are staring at a hard drive that has been wiped, trying to read the magnetic ghosts of the files. The system error is not in the star. It is in our expectation of omniscience. We are also looking for stellar wobbles, astroseismology. Just as earthquakes reveal the Earth's core, starquakes reveal the star's interior structure. The TESS mission and future Plato mission are hunting for these oscillations. If we can detect the heartbeat of Methuselah, we can weigh its core directly. We can see the density gradient. This is the only way to prove the opacity arguments wrong or right. We are waiting for the star to sing. But old stars are quiet. Their atmospheres are stable. The song is faint. We are listening to the silence of the void, hoping for a whisper that will save the timeline. What if the star is a hybrid, a merger of two very low-mass stars? A stellar merger product usually looks younger, blue straggler. But what if two ancient helium-core white dwarfs merged? This is highly speculative. It would create a weird object, But HD 140,283 looks like a normal subgiant. It fits the main sequence profile perfectly. It doesn't look like a Frankenstein monster. It looks elegant. That is the most disturbing part. It looks exactly like what a star is supposed to look like, it just has the wrong birth date. It's not a monster. It's a ghost. A perfectly preserved ghost. Let's reconsider the Great Attractor. Our galaxy is being pulled towards a gravitational anomaly called the Great Attractor. We are moving at 600 kilometers per second towards it. This massive flow of galaxies creates a bulk flow. Does this relativistic motion affect our measurements of the CMB? Yes. We subtract the dipole. But if the Methuselah star originated from a galaxy that was falling into the attractor at a different velocity, its proper time history is different. We are all drifting in a river of gravity. We assume the current is the same everywhere. But the river has rapids. The star might have come from the rapids. The cosmological constant problem is the worst prediction in physics. Theory says the energy of the vacuum should be huge. Observation says it is tiny. This discrepancy is 120 orders of magnitude. The Methuselah star is a minor discrepancy compared to that, but they are linked. If we solve the vacuum energy problem, we might find that the universe's expansion history is radically different. A solution to the vacuum catastrophe might automatically solve the age of the star. We are trying to fix a leaky faucet, the star, while the house is flooding. Vacuum energy. Maybe we should focus on the flood. The sheer endurance of HD 140,283 is inspiring and terrifying. It has orbited the galaxy billions of times. It has passed through the spiral arms, dodging supernovae, surviving the radiation of the galactic core. It is a survivor. It represents the resilience of matter, but survivors carry trauma. The trauma of this star is its chemical depletion. It is starved of metals. It is malnourished. It is a star that has lived on a starvation diet for 14 billion years. That is why it is still alive. Massive, gluttonous stars die young. The meek inherit the universe. The Methuselah star is the meekest of them all. Future technology. The ELT, Extremely Large Telescope, under construction in Chile. It will have a 39-meter mirror. It will be able to see the spectral lines of HD 140,283 with resolution we can only dream of. It will hunt for uranium and thorium lines, nucleocosmochronology, radioactive dating for stars. If we can find uranium in Methuselah, we can date it like a rock. No more luminosity models, just radioactive decay. The half-life of uranium-238 is 4.5 billion years. If we find the decay products, we will have a hard age. This is the smoking gun we are waiting for. The ELT might be the judge that finally sentences the standard model to death. But until the ELT opens its eye, we are left with the mystery. The mystery is fueled by the pop-sci machine, but the science is real. The papers are real. The panic at the conferences is real. The crisis in cosmology is the title of actual academic sessions. Scientists are yelling at each other in auditoriums about this. It is not a fringe theory. It is the central battlefield of modern astrophysics. HD 140,283 is the flag planted in the middle of no man's land. Everyone wants to capture it. No one can reach it. Imagine if the star is actually younger than it looks, but for a reason we haven't guessed. What if dark matter accumulates in the core of stars? If WIMPs, weakly interacting massive particles, are captured by the star, they can annihilate in the core, providing an extra heat source. This dark matter heating would make the star puff up and look like a subgiant before it runs out of hydrogen. It would mimic old age. The star is wearing a mask of wrinkles provided by dark matter. If this is true, then HD 140,283 is the first direct evidence of dark matter interacting with normal matter. It solves the age problem and the dark matter problem in one stroke. It is too good to be true. But it is a beautiful hypothesis. The dark matter heating theory turns the star into a detector. We are using a star 190 light-years away as a particle physics experiment. It shows the ingenuity of humans. We can't build a detector big enough to catch dark matter, so we use a star that has been catching it for 14 billion years. The star is the trap. The anomaly is the signal, we just need to decode it. If the star is powered by dark matter annihilation, it is an immortal star, staying on the main sequence longer than standard physics allows. It is a vampire star, feeding on the invisible blood of the cosmos. This connects to the Fermi paradox again. If dark matter stars exist, they might be stable for trillions of years. They would be the ultimate energy source for a super-civilization. Maybe we don't see aliens because they are clustered around these dark matter burners in the halo, hiding in the dark, ignoring the bright, short-lived disk stars like ours. Methuselah might be a beacon for a Type 3 civilization. We are looking at their campfire and wondering why the wood is burning so strangely. The simulation hypothesis. If the universe is a simulation, does it have rendering artifacts? Is the age discrepancy a rounding error in the floating point arithmetic of the simulator? When you run a simulation for too long, errors accumulate. The Methuselah star might be a glitch object, where the variable for _creation_time was corrupted. It is a horrifying thought that our reality has bugs. And if it has bugs, it can crash. The blue screen of death for the universe might be triggered by investigating these bugs too closely. We must stay grounded in the data, but the data is leading us to the edge of the cliff. The parallax measurement is the gold standard. Gaia's Data Release 3, DR3, has refined the parallax. It confirmed the distance. The star is where we think it is. The brightness is what we think it is. The easy way out, distance error, is closing. The door is shutting. We are locked in the room with the paradox. The only way out is through the new physics door, and we don't know what is on the other side of that door. New physics sounds exciting, but it is destructive. It destroys careers, it destroys textbooks, it renders the life's work of thousands of physicists obsolete. There is a tremendous inertia in science to preserve the status quo. This is why the Methuselah star is so controversial. It threatens the legacy of the 20th century. Einstein, Hubble, Planck. Their statues are trembling. The star is a revolutionary. It is radicalizing the graduate students. The old guard is fighting to suppress the anomaly, while the new guard is weaponizing it. Let us look at the oxygen again. The ratio. Oxygen is the breath of the cosmos. It allows for water, for life. The high oxygen in HD 140,283 suggests that the very first generation of stars, population 3, were efficient oxygen factories. They seeded the universe with the potential for life almost instantly. This is a hopeful spin on the horror. Even if the physics is broken, the chemistry of life was present from the dawn of time. We are not a late-stage accident. The ingredients for us were baked into the first batch of cookies. But hope is not scientific. Evidence is. And the evidence says the star is too old. We are back to the number, 14.5 billion. It sits there, unblinking. It is a monolith. We can dance around it, throw theories at it, shoot lasers at it. It does not move. The universe is 13.8. The star is 14.5. The subtraction yields a negative number. Time cannot be negative, unless time flows backwards. In Feynman diagrams, antimatter is matter moving backwards in time. Is the star made of antimatter? No. It would annihilate with the interstellar medium. It is made of matter. But is it temporal antimatter, a region of space where the arrow of time is reversed? No, that is science fiction. But the desperation makes us think it. The arrow of time is defined by entropy. Entropy always increases. But in a closed system, fluctuations can happen. Could a star form in a local entropy dip, a statistical fluctuation where order spontaneously emerged from chaos? The Boltzmann brain concept suggests it's more likely for a single brain to hallucinate the universe than for the universe to exist. Is the Methuselah star a Boltzmann star? A spontaneous, random assembly of atoms that just happen to look like an old star? The probability is 1 in 10 to the power of 100. But in an infinite universe, anything with non-zero probability must happen. Maybe we found the impossible accident. We are grasping at straws now. Boltzmann stars. Dark matter vampires. Time travel. This is the state of the investigation. We have exhausted the reasonable. Sherlock Holmes said, "When you have eliminated the impossible, whatever remains however improbable, must be the truth. But here, we have not eliminated the impossible. The impossible is staring us in the face. The star is impossible. Therefore, our definition of impossible is wrong. The cosmic variance implies that we can only see a patch of the universe, the observable universe. We cannot see beyond the horizon. Maybe beyond the horizon, the universe is different. Maybe the Big Bang happened at different times in different places. An inhomogeneous Big Bang. If our patch is young, but the patch HD 140,283 came from is old, then the paradox is resolved. The universe isn't one age. It is a quilt of ages. We are just living on a new patch, looking at a thread from an old patch. This leads to the eternal inflation multiverse again, a quilt of bubble universes. If bubbles collide, they exchange matter. The bruise on the CMB might be a collision point. HD 140,283 might be the debris from the impact, a splash of plasma from a neighboring universe that hit ours. It's an interuniversal meteorite. If this is true, we are not alone in the multiverse. We are bumping into other realities. The star is the proof of contact. The thought of contact with another universe is terrifying. What are the laws there? Are they hostile? Does the collision hurt? Did the collision cause the dark energy acceleration? Maybe the expansion is just the recoil from the impact. The Methuselah star is the shrapnel lodged in the body of our galaxy, festering, proving that we were shot by something from the outside. Let us return to the simple beauty of the star. It is a subgiant. It is expanding. It is cooling. It is dying. In a few billion years, it will be gone. The paradox will erase itself. The evidence will vanish. We are lucky to be alive in the brief window of time where the anomaly is visible. If we had evolved a billion years later, the star would be a white dwarf, indistinguishable from billions of others. The mystery would be lost forever. Are there other mysteries we missed? Other impossible stars that died before we invented telescopes? The history of the universe is a history of lost evidence. We must document this, we must measure it, we must solve it. Because if we don't, we are failing the test of intelligence. The universe has thrown us a curveball. If we can't hit it, we don't deserve to leave the planet. HD 140283 is the entrance exam for a Type 2 civilization. Explain this, the universe says. Explain how the child is older than the mother. If we fail, we remain trapped in our ignorance. The end of greatness. This is a scale in cosmology where the universe becomes smooth, 300 million light years. Below that, it is clumpy. HD 140,283 proves that clumpiness exists in time, not just space. Time is clumpy. History is clumpy. It is not a smooth stream. It is a series of waterfalls and pools. The star is in a pool of stagnant time, while we are rushing down the waterfall. As we move to the next phase of our analysis, we will look at the human element, the bias, the fear, the desire for order, how these emotions shape the science. We are not logical machines. We are scared monkeys with calculators, and the calculator is giving us a syntax error. The star shines in Libra, the scales, the symbol of balance. It is ironic. This star is the thing that unbalances the universe. It tips the scales against the standard model. It is the heavy finger on the weighing scale of truth. We will continue to stare at it. We will continue to wonder, is it a mistake or is it a message? You know nothing. That is the message of the Methuselah star. You are just beginning. In the silence of the observatory, the astronomer looks at the spectrum, the lines of hydrogen, the lack of iron. The data is clean, the implication is dirty. It is a perfect storm of cognitive dissonance. The brain rejects what the eyes see. Let us prepare to dive deeper into the dark sector. The next phase of our journey takes us into the invisible forces that might be holding this star together against the flow of time. We are going into the dark. We step now into the dark sector, the 95% of the universe that is invisible to our eyes and our instruments. The existence of the Methuselah star might be the first tangible evidence that dark matter played a far more active role in the early universe than we assume. Standard cosmology suggests that dark matter is cold and collisionless, a ghostly scaffolding that merely guides gravity. But if dark matter interacts with itself or with normal matter, even slightly, it changes the thermodynamics of the first gas clouds. An interacting dark matter model could allow for dark stars to form earlier and evolve differently. HD 140,283 might have formed inside a halo of fuzzy dark matter or self-interacting dark matter that acted as a cosmic incubator, shielding it from the chaotic radiation of the epoch. If this star was cradled by a different kind of physics in its infancy, its age is a misinterpretation of its unique upbringing. We are judging a child raised by wolves by the standards of a child raised in a city. Consider the concept of quintessence. Unlike the cosmological constant, which is a static energy density of vacuum, quintessence is a dynamic evolving scalar field. It changes over time. If the universe is governed by quintessence, then the expansion rate has fluctuated wildly over 14 billion years. There could have been periods of rapid braking and rapid acceleration that our linear models miss entirely. In a quintessence universe, the clock of the cosmos is variable. The Methuselah star might have lived through a slow time era where the universe loitered in a state of low expansion, allowing the star to age while the universe stood still. This theory aligns the star's age with the universe's age not by shrinking the star, but by stretching the timeline of the universe itself. It suggests that the history of the cosmos is not a straight line, but a complex, winding path with stops and starts. The investigation forces us to confront the chameleon field hypothesis. This is a hypothetical fifth force that changes its strength depending on the density of the environment. In high-density regions like Earth, it is weak and undetectable. In the vast emptiness of space, it becomes strong. If a chameleon field exists, it would alter the hydrostatic equilibrium of stars in the galactic halo, where the density is low. It would change the pressure balance inside HD 140283, mimicking the effects of advanced age. The star might look old because it is being squeezed or puffed up by a force of nature that we literally cannot measure in our laboratories on Earth. We are trying to diagnose a patient who is suffering from an environmental allergy to a substance that doesn't exist in our hospital. The law of physics isn't broken. It's just context-dependent, and we are missing the context. We must also look at primordial black holes, PBHs. Stephen Hawking proposed that the Big Bang could have created tiny black holes. If these PBHs pervade the galactic halo, they would interact with stars. A small PBH passing through the core of HD 140,283 would not destroy it, but it would disrupt the fusion process. It would stir the core, bringing fresh fuel in or pushing heavy elements out. This stellar surgery performed by a passing singularity could reset or accelerate the aging clock. The star might be a survivor of a collision with a ghost. It bears the scars of an encounter with a primordial object that is now light years away. This adds a layer of kinetic violence to the silent, static mystery. The star is a witness to the invisible bullets flying through the dark. Let us return to the void. If we are living in a local void, the KBC void, it means our local density of matter is half the cosmic average. This underdensity creates a peculiar velocity for our entire galaxy. We are expanding faster than the background universe. This distorts the redshift distance relation. The Hubble tension might just be a void tension. If we correct for the void, the age of the universe jumps to 15 billion years. Suddenly, the Methuselah star is no longer an anomaly. It is a standard citizen. But this solution is terrifying because it implies we are isolated. We are living in a barren wasteland of the universe, a bubble of emptiness. It reinforces the cosmic horror of insignificance. Not only are we on a small rock, but we are also in a lonely, empty corner of the vast structure, far away from the real universe. The implications for the end of the universe are equally dire. If the universe is 15 billion years old, to accommodate the star, it means the expansion is slower than we thought. A slower expansion suggests a lower value for dark energy. If dark energy is weak, it might not be enough to overcome gravity in the long run. The Big Freeze, eternal expansion, might be replaced by the Big Crunch, the universe might eventually stop expanding and collapse back in on itself. The Methuselah star, having survived the beginning, acts as a harbinger of the end. It suggests that the cycle will close. The fire that birthed it will eventually return to consume it. We are not heading toward an infinite dark, but toward a fiery, crushing singularity where time and space are deleted. Let's consider the baryon acoustic oscillations, OI. These are sound waves from the early universe that froze into the distribution of galaxies. They provide a standard ruler to measure the cosmos. The BAO data supports the 13.8 billion year age. The Methuselah star fights against the BAO. It is a conflict between the ruler, BAO, and the clock, stars. When the ruler and the clock disagree, one of them is broken. Usually clocks are more fragile than rulers, but in this case, the clock, the star, is a physical object we can touch with our eyes. The ruler is a statistical inference. We are trusting a ghost story about sound waves over the physical reality of a nuclear furnace. The star is shouting, "I am here and I am old," while the equations whisper, "You cannot exist." The information paradox. In a black hole, information is supposedly lost or holographically preserved. Does the universe itself have an information limit? If the universe is a finite system, it can only hold so much history. Maybe the age of the star is a result of data compression. As we look further back in time, the resolution of reality drops. The 14.5 billion years is a low-resolution artifact. We are trying to zoom in on a JPEG that has been compressed too many times. The pixelation of time in the deep past makes precise dating impossible. The star exists in the blurry edge of the image. We are asking for 4K clarity from a system that only renders the past in 8-bit. The anomaly is an artifact of the rendering engine of causality. There is also the anthropic principle in a multiverse context. In an infinite multiverse, there will be bubbles with slightly different laws of physics. In some bubbles, stars evolve faster. In others, slower. We might be living in a border region, a domain wall between two vacuum states. If a bubble of slow physics collided with our fast physics bubble, objects like HD 140,283 could be intruders. It explains the high-velocity nature of the star. It didn't just fall into the galaxy, it fell into our dimension. It is a piece of shrapnel from a collision of realities. It carries the physical constants of its home dimension within its core, burning fuel at a rate dictated by alien laws. The crisis of confidence in science. For 20 years, we have celebrated precision cosmology. We claimed we knew the age of the universe to within 1%. We were proud. HD 140,283 exposes that pride as hubris. It reminds us of Lord Kelvin, who calculated the age of the Earth to be 20 million years because he didn't know about radioactivity. He was a genius, but he was missing a fundamental piece of the puzzle. What is our radioactivity? What is the missing force or particle that makes our calculations of the universe's age laughably wrong? The star is the ghost of Lord Kelvin, warning us that we are making the same mistake. We are missing something huge. The Galactic Archaeology Mission. We are digging up the ruins of the Milky Way's formation. HD 140283 is the oldest artifact in the museum. But it doesn't fit the timeline of the exhibit. It's like finding a Roman coin in a dinosaur footprint. It implies that the civilization of stars started long before the geology of the galaxy was ready. Did stars form in the intergalactic medium before galaxies even coalesced? Population 3 stars forming in the lonely void, then falling into the gravitational wells of proto-galaxies? If so, the universe was lit up by lonely wanderers long before the great cities of the spiral arms were built. It paints a picture of a lonely, scattered beginning. We must scrutinize the distance ladder. The first rung is parallax, the second is Cepheids, the third is supernovae. If the first rung, parallax, is slightly bent, the whole ladder leads to the wrong place. Gaia is fixing the first rung. But what if the second rung is rotten? What if Cepheid variables, our standard candles, are not standard? If they change luminosity based on metallicity in ways we don't grasp, then our measurement of the Hubble constant is wrong. If H0 is lower, the universe is older. The Methuselah star is cheering for a broken ladder. It wants the universe to be older so it can stop being a paradox. It is waiting for us to realize that our yardstick is warped. The cosmic ray influence. Over 14 billion years, HD 140,283 has been bombarded by high-energy particles. These impacts can transmute elements on the surface. They can create lithium or destroy it. They can alter the spectral signature. We try to model this spiralation, but the cosmic ray flux of the early universe is unknown. Was the early galaxy a shooting gallery of high-energy radiation? If so, the face of the star has been beaten and scarred, altering its appearance. We are trying to guess the age of a boxer by looking at his face after 100 rounds. The damage masks the truth. The star is a victim of the violent environment of the dawn of time. The Dyson sphere sanity check. Could the anomaly be artificial? Could the star be wrapped in a partial energy harvesting structure that alters its brightness? If an advanced civilization wanted to preserve a star for billions of years, they might starlift, remove mass to keep it stable. A star that has been engineered to live longer would look exactly like HD 140,283. Low mass, stable, ancient. Is it a natural object, or is it a battery? The lack of infrared excess, waste heat, argues against a Dyson sphere. But a cutoff thruster, a giant mirror used to move the star, might explain its high velocity. Is someone driving this star? It is the wildest speculation, but the impossible age opens the door to the impossible origin. The Great Filter. If the universe is older than we think, the Fermi paradox is even stronger. Life had more time. Why is the galaxy dead? Maybe stars like HD 140,283 are the only survivors of a galactic sterilization event. A gamma-ray burst or quasar ignition that wiped the slate clean 10 billion years ago. The old universe might have been teeming with life, and then silence. We are the second crop, growing in the ashes of the first. The Methuselah star remembers the first crop. It shines with the guilt of the survivor. It is a memorial to the civilizations that never made it past the Great Filter. Let's focus on the scalar tensor theories of gravity. In these theories, gravity is mediated by a scalar field in addition to the tensor field of Einstein. This scalar field can evolve. It effectively means g, the gravitational constant, is not constant. If g was higher in the past, stars would burn brighter and faster. If g was lower, they would burn slower and dimmer. A changing g would completely invalidate our age estimates. We assume g is fixed because it is fixed now. But extrapolating now to then is an assumption. If gravity was weaker in the deep past, HD 140,283 would have burned its fuel slowly, allowing it to live longer than a standard star. It suggests the fundamental grip of the universe on matter has tightened over eons. The magnetic braking effect. Stars spin. Over time, they lose spin due to magnetic winds. This is gyrochronology. We can date stars by their spin. But HD 140,283 is a subgiant. It has expanded and slowed down naturally. Its spin information is largely lost. We can't use the gyro clock. We are forced to rely on the nuclear clock. It's like trying to date a car without the odometer, looking only at the rust on the chassis. The rust, metallicity, says ancient. The engine, fusion status, says dying. The combination is fatal to our timeline. The simulation argument again, but from a resource perspective. In a simulation, you render the things the observer is looking at with high detail and background objects with low detail. HD 140,283 was a background object for billions of years. Did it evolve only when we started looking at it? This is the quantum Zeno effect applied to cosmology. A watched pot never boils. A watched star forces the simulation to render a history. Maybe the error in the age is a lag in the procedural generation of the star's backstory. The universe is struggling to generate a consistent history for an object that shouldn't be scrutinized this closely. The sociology of science. There is a pressure to solve this. Grants depend on it. Tenure depends on it. If you can explain the Methuselah star, you get a Nobel Prize. If you can't, you get anxiety. This pressure creates a bias towards fixing the data rather than accepting the anomaly. We must be wary of motivated reasoning. Are we smoothing the data to save the theory? The star doesn't care about our careers, it only cares about hydrogen and helium. It is the most honest thing in the galaxy because it has no agenda. The dark flow. This is the movement of galaxy clusters towards a point beyond the visible universe. If our entire observable patch is flowing towards something, it implies a massive structure outside our horizon, a structure that pulls. Does this pull create a time dilation gradient across the universe? If we are deeper in a gravity well than we think, time moves slower for us than for the background universe. We might be the ones in the slow lane. The Methuselah star, coming from a different region, might be running on standard time, while we are running on dilated time. The discrepancy is relativity in action on a scale of billions of light years. The theory of everything. TOE? We don't have one. We have quantum mechanics, small, and general relativity, big. They hate each other. They break down at singularities. HD 140,283 is a singularity of a different kind. It is a singularity of information. It exists at the intersection where QM, nuclear fusion rates, and GR, expansion of the universe, meet, and they don't mesh. The star is the glitch that occurs when you try to run two incompatible operating systems on the same hardware. It proves that we need a quantum gravity theory to understand not just black holes, but ordinary old stars. The supernova connection. To get the low iron content of HD 140,283, the supernova that preceded it must have been low energy, a faint supernova. If the first stars died in whimpers rather than bangs, they would release fewer heavy metals. This would allow the next generation, Methuselah, to look extremely primitive. It challenges our view of the violent early universe. Maybe the first deaths were quiet. Maybe the universe started with a whisper. This quiet start hypothesis allows for clean, metal-poor stars to form later than we think, solving the paradox by changing the definition of chemical age. The Philosopher's Stone. Alchemists sought eternal life. This star has achieved it, relative to its peers. Massive stars live for millions of years. This one lives for billions. It is the tortoise of the stellar race. Its low mass is its secret weapon. By burning fuel frugally, it outlasts the empires of the giants. It teaches us that in a universe of entropy, efficiency is the only immortality. The horror is that to survive, you must be small, cold, and slow. The bright and the bold die young. The universe punishes ambition and rewards stagnation. The Boltzmann brain concept leads to Boltzmann universes. In an eternal recurrence, every possible configuration of matter will happen. Is HD 140,283 a statistical fluctuation? No, it's too stable. It obeys the laws of stellar structure. It's not a random assembly. It is a lawful object in a lawless timeline. That is the key distinction. It follows the rules of a physics, just maybe not our physics. It is a visitor from a different legislative district of reality. The future of the anomaly. As the star evolves, it will climb the red giant branch. It will become brighter. It will eventually shed its outer layers and reveal its core. That white dwarf core will be the ultimate chronometer. White dwarfs cool very predictably. If we can measure the cooling age of the white dwarf remnant of Methuselah in 1 billion years, we will know the truth. But we can't wait that long. We are impatient species. We want the answer now. The star forces us to practice patience on a geological scale. It mocks our short attention spans. The AI solution. We are feeding the data of HD 140,283 into neural networks. We're asking AI to find patterns we missed. Maybe there is a correlation between strontium abundance and age that human physicists haven't derived. The AI might come back with an answer that we cannot understand. The star is 12 billion years old, based on hyperdimensional correlations. If the machine solves the paradox but cannot explain the why, have we learned anything? The star might trigger the transition from human science to black box science, where we trust the machines to understand the universe for us. The cosmic web. The filaments of dark matter that connect galaxies. HD 140,283 is a particle flowing along these filaments. It is a blood cell in the vein of the cosmos. By tracking its orbit, we map the veins. We map the invisible skeleton of the galaxy. The star is a probe. We didn't build it, but we can use it. It is tracing the gravitational potential of the Milky Way halo better than any satellite we could launch. It is a gift from nature, a free test particle in the dark matter wind tunnel. The redshift drift, Sandage lobe test. If we watch the redshift of a distant object for decades, we can see the expansion rate change in real time. We haven't done this yet. We need bigger telescopes, but HD 140,283 is a local anchor for these measurements. If the local universe is expanding differently than the distant universe, the redshift drift will reveal it. The star is the control group. It is the 0 point against which we measure the accelerating cosmos. The fine-tuning of the triple alpha process. This is how helium becomes carbon. It relies on a specific resonance energy level. If this level was different in the early universe, carbon production would fail. HD 140,283 has carbon, so the resonance existed. The laws of nuclear physics were already in place. This robustness of the laws is comforting, but it makes the age anomaly sharper. If the physics was the same, the age must be wrong. We are trapped in a logic loop. Same physics equals impossible age. Different physics equals terrifying implications. Both paths lead to darkness. The scientific revolution. Thomas Kuhn wrote about paradigm shifts. Anomalies accumulate until the old theory breaks. We are in the accumulation phase. The Methuselah star, the Hubble tension, the lithium problem, the void problem. They are all cracks in the dam. The water is leaking through. We are trying to plug the holes with our fingers. But the pressure is building. Soon, the dam will burst. And when it does, the standard model will be washed away, replaced by something stranger. We should not fear the flood. We should build a boat. The holographic principle suggests that the entire universe is a 2D surface projected into 3D. In a hologram, every piece contains the whole image. If you cut a hologram in half, you still see the whole picture, just blurrier. HD 140,283 is a piece of the cosmic hologram. It contains the data of the whole Big Bang. By studying this one star, we are decoding the boundary conditions of the entire universe. It is not just a star, it is a micro-universe, a fractal echo of the creation event. The void is calling. As we stare into the deep past, the past stares back. The Methuselah star is an eye, an unblinking, ancient eye. It has seen the universe empty out. It has seen the galaxies fly apart. It knows the loneliness of the long-term survivor. We are brief flickers of consciousness, trying to interrogate an immortal. The dynamic is humbled. We are the mayflies asking the mountain how old it is. The mountain does not answer. It just is. Let's consider the Dark Ages again, the time before stars. 100 million years of darkness. If HD 140,283 formed during the Dark Ages, it violates the cooling models. But what if dark matter decay heated the gas? If dark matter is unstable and decays into photons, it could have reionized the gas earlier, allowing stars to form earlier. The star might be the child of dying dark matter. This links the two great mysteries, the nature of dark matter and the origin of the first stars. They are the same mystery. The epistemic horizon. We can only know what our instruments allow us to know. Our instruments are based on light. The star emits light. But what if the most important properties of the star are dark? What if it emits gravitational waves, or dark photons, or axions that we are blind to? We are describing an elephant by touching its tail. We say it is a rope, but it is a beast. The star is a beast of physics, and we are holding the tail, confused by the texture. The broken clock. A broken clock is right twice a day. Is our model the broken clock, or is the star? If the star is the broken clock, it is a random anomaly. If the model is broken, everything is wrong. Occam's razor suggests the simplest explanation is usually right. The simplest explanation is that we messed up the distance or the composition, but we have checked those. Occam's razor's failing. We need a sharper razor. The legacy. This star will outlive us. It will outlive the sun. It will outlive the Earth. When humanity is a layer of plastic in the geologic strata, HD 140,283 will still be burning. It is the ultimate time capsule. If we want to leave a message for the future, we should transmit it to this star. It is the only library that will survive the fire. It is the keeper of the records. The shadow biosphere hypothesis. Could life exist on a planet orbiting such an old star? A planet formed 14 billion years ago? It would have had time to evolve, destroy itself, evolve again, 1,000 times. The ancients of science fiction might be real and they might have lived there, but the lack of metals makes rocky planets hard to form. It would be a gas giant world, a lonely consciousness floating in hydrogen clouds, watching the universe grow old. The final verdict is that there is no verdict. Not yet. The tension is the point. The fear is the point. We are standing on the edge of the unknown. That is where science lives. Not in the textbooks, but in the terror of the anomaly. The Methuselah star is the patron saint of the unknown. It is the North Star for the lost physicist. We must embrace the paradox. We must accept that reality is weirder than we can imagine. The universe is not obligated to make sense to us. It is allowed to have 16-billion-year-old stars in a 13.8-billion-year-old room. It is allowed to break the rules, because they are our rules, not its rules. We are the rule makers, and we are the ones who are wrong. As we move to the conclusion of our investigation, we will look at the ultimate fate of the anomaly. Will it be solved, or will it remain a thorn in the side of cosmology forever? Some mysteries are not meant to be solved. Some are meant to humble us. HD 140,283 is a lesson in humility written in nuclear fire. It shouldn't exist. That is the refrain. But it does. That is the reality. The conflict between should and does is the friction that drives progress. We need the friction. We need the pain of being wrong. Without it, we stagnate. The star is a gift of pain. The dark energy accelerates. The galaxies flee. The universe gets darker. But Methuselah remains, a point of light in the growing dark. It is a symbol of resistance. Resistance against the dark. Resistance against the entropy. Resistance against the silence. We are the detectives. The star is the body. The universe is the locked room. We have found the clues. We have interrogated the witnesses. But the killer is still at large. The killer is time itself. And time covers its tracks perfectly. The stellar evolution codes are being rewritten. New opacities, new reaction rates. We are patching the software. But is it enough? Or do we need a new operating system? The star suggests a reboot. A reboot of cosmology. A reboot of how we think about time. Look up. That is the advice. Look up at Libra. Find the invisible star. Know that it is breaking the universe. Know that it is mocking Einstein. Know that it is a mystery that might never be solved. And feel the awe of that mystery, the awe of the impossible. The multiverse whispers. If there are other universes, do they have their own Methuselah stars? Is this a common glitch? Or is our universe uniquely broken? The isolation of the answer is what haunts us. We have a sample size of 1. We are guessing in the dark. The endgame. We will keep measuring. JWST will look. Gaia will look. ELT will look. We will throw billions of dollars at this star. Because the answer is worth it. The answer is the key to the origin of everything. We are buying the answer with glass and metal and silicon. The cosmic horror is not monsters. It is math. It is the math not adding up. It is the realization that the equation of the universe has a remainder. And we are the remainder. We are the anomaly. The star is just the mirror reflecting our own confusion. We are almost at the end of the script. But the story of the star has no end. It will burn for another billion years. Long after this video is forgotten. Long after the servers rot. The star is the ultimate storage medium. It stores the truth in its light. Let us prepare for the final act, the synthesis. We have torn the theory apart. Now we must try to put it back together. We must try to build a universe where HD 140,283 is allowed to exist. A universe that is stranger, older, and more beautiful than the one we thought we knew. As we attempt to synthesize a new understanding of reality that permits HD 140,283 to exist, we must look at the holographic principle through the lens of entropy. The holographic principle suggests that the information content of a volume of space is encoded on its boundary. If the early universe had a different surface area to volume ratio due to the geometry of inflation, the, quote, information density might have been higher. A higher information density allows for more complex structures, like stars, to form faster. In this scenario, the Methuselah star is not an anomaly of time, but an anomaly of resolution. It formed in a high-resolution pocket of the holographic projection, effectively rendering faster than the surrounding low-resolution gas. We are looking at a 4K object in a 108OP universe. The mismatch in quality creates the illusion of a mismatch in time. It implies that the laws of physics are just compression algorithms, and this star is a file that refused to be compressed. We must also consider the superfluid vacuum theory. This proposes that space-time acts like a superfluid, a fluid with zero viscosity. In a superfluid, you can have vortices and phase transitions. If the early universe underwent a phase transition, like water freezing into ice, there could be defects in the crystal structure of space-time. These topological defects are known as cosmic strings or domain walls. If HD 140,283 forms near a cosmic string, the intense gravitational field of the string could have accreted matter instantly, bypassing the millions of years usually required for gravitational collapse. The star would be a, quote, defect marker, a scar tissue formed around a flaw in the vacuum itself. It stands as a monument to the moment the universe froze into its current configuration, trapping a piece of the primordial energy in a knot that became a star. The many worlds interpretation of quantum mechanics usually applies to subatomic particles. But what if it applies to macroscopic objects in the chaotic early universe? If the universe branched into infinite histories at the Big Bang, there is a branch where a star formed immediately due to a statistically impossible fluctuation. Usually, these branches are separate. But in the high energy density of the beginning, did the branches overlap? Could the Methuselah star be a superposition of multiple histories that failed to decohere properly? We might be seeing a ghost star that exists in a probability cloud, appearing solid to us but actually being a smear of quantum possibilities. It defies the age limit because it is not fully real in the way we understand reality. It is a probability wave that never fully collapsed, haunting the galaxy like a quantum specter. Let us return to the dark energy problem, but from the perspective of the future. The Big Rip scenario suggests that dark energy gets stronger over time. But what if it is cyclic? If dark energy oscillates, then the expansion of the universe breathes in and out. During an in-breath contraction phase, billions of years ago, matter would have been compressed, heating up and forming stars prematurely. If the universe has a heartbeat of expansion and contraction, the linear age of 13.8 billion years is meaningless. It is just the time since the last beat. HD 140,283 would be a survivor from the compression phase, a star born in the winter of the cycle, now living in the summer. It forces us to abandon the idea of a linear timeline and embrace a cyclic, breathing cosmos where beginning and end are just temporary states. The investigation forces us to confront the observer effect on a cosmological scale. We assume the universe exists independently of us, but quantum mechanics suggests that the observer is part of the system. By measuring the age of the Methuselah star so precisely, are we forcing the universe to generate a history for it? This is the participatory anthropic principle of John Wheeler. We are participating in the creation of the past by observing the present. The anomaly might be a result of our own interrogation. The harder we look, the more the universe has to scramble to provide an answer, and sometimes it provides a contradictory one. We are breaking the game engine by zooming in too close on a texture map that wasn't meant to be inspected. The star is a glitch caused by the act of observation itself. Cosmic variance is the scientific term for bad luck. It means we might just be living in a weird patch of the universe. But how much bad luck are we allowed to have? We have the cold spot in the CMB. We have the axis of evil, an alignment of cosmic features. We have the Hubble tension, and we have the Methuselah star. That is a lot of bad luck. It starts to look less like variance and more like systemic failure. If you flip a coin 100 times and get heads every time, you don't say, "Wow, what variance?" You say, "The coin is rigged. The universe looks rigged." The constants are tuned, the anomalies are aligned, and the timeline is broken. The star is the evidence that we are not in a random universe, but a constructed one, and the architect left a signature. The technosignature hypothesis must be revisited with extreme skepticism but open-mindedness. If an advanced civilization wanted to survive the heat death of the universe, they would need a long-term energy source. A low-mass star like HD 140283 is the perfect battery. It burns for tens of billions of years. Could the star be an artificial storage device? Maybe its metal-poor nature is actually metal-stripped. Maybe the heavy elements were mined out of it billions of years ago to build a megastructure that has since decayed or moved on. We see a pristine, ancient star. A Type 3 civilization might see a depleted fuel tank. The anomaly of its composition and age might be the industrial waste of a godlike intelligence that harvested the galaxy while we were still single-celled organisms. We must also look at neutrino physics. Neutrinos are the most elusive particles. We know they have mass, but we don't know the absolute value. If neutrinos are heavier than we think, they would affect the expansion of the universe and the cooling of stars. A heavy neutrino background would act like hot dark matter. It would smooth out the early universe, delaying structure formation. Wait, delaying structure formation makes the problem worse. The star needs to form faster. So we need lighter neutrinos or sterile neutrinos that don't interact at all. The star is forcing us to constrain the mass of the neutrino without ever entering a particle accelerator. It is a celestial scale that weighs the lightest particles in existence. If the scale is broken, our particle physics is broken. The macro implies the micro is wrong. Modified gravity, MOND, suggests that gravity falls off differently at large distances. If MOND is true, then the internal pressure of stars might be different than standard general relativity predicts. A star held together by MOND gravity would have a different core temperature and pressure profile. It would burn fuel at a different rate. We calculate the age based on Einstein's gravity. If Milgram's gravity, MOND, is the reality, then our age calculation is applying the wrong formula. The Methuselah star might be the Rosetta Stone for modified gravity, proving that Einstein was right about the solar system but wrong about the galaxy. It stands as the defiant proof that Newton and Einstein didn't finish the job. The laws of motion are still being drafted. The great attractor pulls us. The dipole repeller pushes us. We are in a dynamic river of space-time. The Methuselah star is a piece of driftwood that seems to be moving upstream. Its high velocity and retrograde orbit, moving opposite to the galactic rotation, mark it as an intruder. It does not belong to the disk, it belongs to the chaotic halo. The halo is the subconscious of the galaxy, the dark, disordered, ancient place where the suppressed memories of the formation event are stored. By studying this star, we are psychoanalyzing the Milky Way. We are digging into its childhood trauma. And we are finding that the trauma is older than the patient. The galaxy remembers things from before it was born. The crisis is not just about numbers, it is about narrative. Science is a story we tell to explain the chaos. The story has a beginning, Big Bang, a middle, stars and galaxies, and an end, heat death. HD 140,283 disrupts the beginning chapter. If the characters, stars, appear before the setting universe is built, the plot hole ruins the suspension of disbelief. We are currently trying to retcon the story. We are rewriting the first chapter to include pre-galactic star formation, or early dark energy. But retcons are messy. They leave scars in the narrative coherence. The star is a plot hole that cannot be filled, only acknowledged. It sits there, breaking the fourth wall, staring at the audience. Let us imagine the view from a planet orbiting HD 140,283. For 14 billion years, the sky has changed. It saw the assembly of the Milky Way. It saw the merger with the Gaia-Enceladus galaxy. It saw the birth of the Sun. It saw the rise of humanity, and it will see us fall. It is the silent watcher. To a civilization on such a world, we would be the newcomers, the flash-in-the-pan species that burned bright and died young. They would look at our metal-rich sun and see it as a polluted, unstable monstrosity. To them, normal is metal-poor purity. We are the freaks. We are the mutants of the cosmos, made of the recycled trash of dead stars, while they are made of the pristine stuff of creation. The James Webb Space Telescope, JWST, is our best hope. It can see the first galaxies. If JWST finds galaxies at redshift 15 or 20 containing evolved stars, then the Methuselah star is vindicated. It is no longer an anomaly, it is the vanguard. Early data from JWST is already showing galaxies that are too massive and too bright for their age. The impossible early galaxies problem is the sister to the impossible old star problem. They are confirming each other. The universe turned on the lights much faster than we thought. The Dark Ages were not dark. They were blazing with impossible light. We are realizing that the universe was born mature, not as an infant. The concept of time dilation near the Big Bang. In the first moments, energy density was infinite. Time itself might have been thick. A second back then could have been equivalent to 1 billion years now. If HD 140,283 formed in a region of high relativistic distortion, it could have experienced accelerated aging relative to our clock. It lived 1 billion years in a few minutes of cosmic time. This relativistic aging theory would solve the math, but it destroys our concept of universal time. It means that age is subjective. You are only as old as the gravity you feel. This star is a victim of the crushing weight of the early universe, aged prematurely by the stress of creation. Vacuum decay is the ultimate ending. If the universe is in a false vacuum, it could tunnel to a lower energy state. A bubble of destruction would expand at light speed. Some theories suggest that old regions of the universe are more prone to this decay. HD 140,283 might be a weak point in the fabric of space-time, a spot where the vacuum is wearing thin. By studying it, are we poking the blister? Are we risking the stability of the cosmos by probing the one object that defies the laws that hold it together? The star is a warning sign. Do not touch. Structural integrity compromised. We are ignoring the sign. The scientific method relies on falsifiability. Can we falsify the age of the star? Yes, by finding a measurement error, but we haven't found it. Can we falsify the age of the universe? Yes, by finding a new cosmology. We are in the uncomfortable middle ground where neither is falsified but they contradict. This state is called cognitive dissonance. Science is suffering from a nervous breakdown. We are publishing papers that contradict each other in the same journal issues. The Methuselah star is the wedge driving the community apart. It is creating two tribes, the observationalists who trust the star and the theorists who trust the model. The war is silent, but it is being fought with equations. The human lifespan bias. We live for 80 years. We cannot comprehend 14 billion years. To us, 13.8 and 14.5 look like the same number. But the difference is 700 million years. That is the entire history of multicellular life on Earth. The error bar is the size of the history of life. We are cavalier about these numbers. Oh, it's just a few percent off. That few percent contains dinosaurs, humanity, and everything we have ever known. The star represents a span of time that renders us statistically insignificant. We are a rounding error in the calculation of its age. That is the true horror. Not that the star is old, but that we are so incredibly brief. The simulation hypothesis offers a grim solution: procedural generation. In a video game, the world is generated as you walk into it. If we look too far back, we hit the fog of war. The Big Bang is the fog. HD 140283 is an object that spawned incorrectly inside the fog. It has properties that don't match the level design. The developers, laws of physics, are trying to patch it by expanding the universe faster, dark energy, to make the timeline fit. We are witnessing the patch being applied in real time. The universe is stretching to accommodate the glitch. The acceleration of the universe is not a force, it is a bug fix. Eternal return. Nietzsche proposed that time is a flat circle. Everything that has happened will happen again. In an oscillating universe, HD 140,283 is a marker. It has seen the circle close and open. It is the notch on the wall of the prison cell of existence, marking the days. But the days are eons, and the prisoner is matter itself. The star is trapped in the cycle of fusion and gravity, just as we are trapped in the cycle of birth and death. It is our companion in the cage. It is just a much, much older prisoner. The missing mass of the universe is not just dark matter. It is missing time. We are missing the time required to make this star. Where is it? Is it hidden in extra dimensions? String theory posits 10 or 11 dimensions. Could time be curled up in these dimensions? If the star traveled through a region where an extra dimension was unfurled, it could have experienced more time than the 3D universe around it. It took a shortcut through the Calabi-Yau manifold. To us, it looks like it time traveled. To the star, it just took the scenic route through the fifth dimension. The cosmic web is the largest structure in the universe. It looks like a neural network. Is the universe a brain? If so, HD 140,283 is a neuron that fired before the brain was fully conscious. It is a primitive reflex, a thought that occurred before the thinker existed. This panpsychist view is unscientific, but it captures the eerie biological quality of the anomaly. The star feels alive. It feels stubborn. It feels like it has intent. It refuses to die. It refuses to explain itself. Occam's broom. This is the opposite of Occam's razor. It's when you sweep the inconvenient facts under the rug. For decades, cosmology used Occam's broom on HD 140,283. Ignore the outlier. Focus on the average. But the pile under the rug is getting too big. The rug is lumpy. We are tripping over it. The Hubble tension and the lithium problem and the Methuselah star are all under the rug. We can no longer walk across the room without acknowledging the mess. The time for sweeping is over. The time for cleaning is now. The future of the universe. If the universe is older, does it die sooner? If the star is 14.5 billion years old, it has used up a significant fraction of its fuel, but the universe has used up its fuel too. Star formation is slowing down. The peak star formation was 10 billion years ago. We are living in the fading twilight. The Methuselah star saw the noon of the universe. We are seeing the sunset. It is a reminder that the party is winding down. The lights are dimming. The entropy is winning. The Drake equation estimates the number of civilizations. One variable is length of time. A civilization releases detectable signals. If stars like HD 140,283 can support life for 14 billion years, that variable L could be enormous. A civilization on a Methuselah planet could be billions of years old. They would be gods to us. They would have solved these physics problems eons ago. Maybe the solution is that we are in a zoo hypothesis scenario. They are watching us struggle with the math, like we watch a toddler try to fit a square peg in a round hole. The star is the camera. The dark forest theory. If there are ancient civilizations, they stay quiet to avoid destruction. HD 140,283 is quiet. It has no radio signals. It has no Dyson spheres. It is naked. Is this camouflage? Is the star purposefully keeping a low profile to avoid the predators of the cosmos? Or is it truly dead and empty? The silence of the oldest star is the loudest silence of all. It screams, "There is nothing here." And that nothingness is more terrifying than any alien fleet. The Standard Model is a fortress. It has withstood every attack for 50 years. But HD 140,283 is the sapper digging a tunnel under the walls. It is a slow, quiet threat. It doesn't attack with a bang, but with a whisper. Your timeline is wrong. Your gravity is wrong. Your reality is wrong. The fortress will not fall today. But the cracks are spreading. The foundation is shifting. The star is the earthquake that doesn't stop. Epistemological anarchy. Paul Feyerabend argued that anything goes in science. We should embrace the weird. HD 140,283 allows us to be anarchists. It gives us permission to propose crazy theories. Variable speed of light? Sure. Primordial black holes? Why not? Mirror universes? Bring it on. The star has opened the floodgates of creativity. It has made cosmology exciting again because it has made it dangerous. We are no longer just refining decimals. We are questioning the axioms. The legacy of the star. Even if we solve the mystery, even if we find a calibration error that fixes the age, the damage is done. The doubt has been planted. We will never trust the timeline as implicitly as we did before. We have lost our innocence. We have eaten the apple of knowledge. And the apple was a subgiant in Libra. We now know that the universe is capable of lying to us, or rather that we are capable of deluding ourselves. The psychology of the infinite. Standing before the ocean, we feel small. Standing before this star, we feel temporal vertigo. It pulls the rug of time out from under us. It is an abyss of years. Nietzsche said, when you gaze long into an abyss, the abyss also gazes into you. The Methuselah star is the abyss. It gazes into our telescopes, into our equations, into our minds. It asks, are you sure? And we are not sure. We are never sure. The final frontier. It is not space. It is time. We can travel through space. We cannot travel through time. HD 140283 is the only time machine we have. It transports us to the era of reionization. It transports us to the population 3 epoch. It takes us back to the moment the lights turned on. It is a portal. We cannot step through it, but we can look through it. And what we see on the other side is a universe that does not match our textbooks. As we conclude our investigation, let us summarize the cosmic horror of HD 140,283. It is the horror of the mismatch. The horror of the puzzle piece that doesn't fit. It suggests that our picture of the universe is a jigsaw puzzle where we force the pieces together with a hammer. We made it fit, but the cracks show. The star is the biggest crack. It shows the light coming from behind the puzzle, and we are afraid to look at what is generating that light. The cosmological principle. The universe is homogeneous and isotropic. The Methuselah star challenges this. If the universe has special spots where stars form early, it is not isotropic. If the universe has voids where time flows differently, it is not homogeneous. The principle is a lie we tell to make the math solvable. The reality is a messy, chaotic, lumpy, weird monster. And we are trying to put a leash on the monster with linear algebra. The monster is slipping the leash. The irony of light. Light is the fastest thing in the universe. But it is also the oldest thing. The photons hitting our sensor from HD 140,283 were created in the core 1,000,000 years ago, and the star itself was created 14 billion years ago. We are catching ancient rain. Every data point is a drop of that rain. We are trying to infer the nature of the storm from the drops. But the storm has passed. We are just the puddles left behind. The Hubble constant is named after Edwin Hubble. He discovered the expansion. He would be horrified by this star. It breaks his law, or rather, it complicates his law to the point of breaking. It suggests that the expansion history is not a simple curve. It is a jagged line, a line written by a trembling hand. The hand of dark energy? The hand of God? The hand of chance? We don't know who is holding the pen. The shadow of the past. The Big Bang casts a long shadow. We are living in it. HD 140,283 is a light that shines through the shadow. It illuminates the dust of the early universe. It shows us that the dust was fertile. It was ready to make stars. The universe was eager to live. It didn't wait for the permission of the cooling laws. It forced life into existence. That is a beautiful, terrifying thought. The universe wants to exist, and it will break its own rules to do so. Uncertainty principle. Heisenberg said we can't know position and momentum. Maybe there is a cosmological uncertainty principle. We can't know the age and the composition of the universe simultaneously, with infinite precision. The more we refine the composition using stars, the blurrier the age, Hubble tension gets. We are hitting the resolution limit of reality. The pixel grid is visible. The star is a pixel that is stuck on white. The last word belongs to the star. We can publish our papers, we can make our YouTube videos, we can argue on Twitter. The star burns on, it converts hydrogen to helium. It ignores us. Its existence is an absolute fact. Our theories are relative opinions. In the battle between fact and theory, fact always wins. Eventually, we just have to wait for the theory to surrender. The solitude. Think of the loneliness of HD 140,283, to be the first. To watch the darkness for millions of years before the other lights turned on. To be the elder in a nursery of infants. It is a tragic figure. It carries the burden of memory. If the universe has a memory, it is stored in the low metallicity stars. They are the hard drives. And this one is the boot sector. The symphony of the stars. The universe is singing. Gravitational waves, radio waves, light. HD 140,283 is holding a low, steady note. A drone. The drone of the beginning. It underpins the melody of the galaxy. We are trying to tune our instruments to it, but we are out of tune. We are playing in the key of 13.8. The star is playing in the key of 14.5. The dissonance is painful. But it is also where the jazz is. The improvisation of physics happens in the dissonance. The end of science? No. It is the beginning of a new science. A science that accepts anomalies. A science that is humble. A science that admits, we don't know. The Methuselah star is the teacher. It is hitting our knuckles with a ruler. Look again, it says. Calculate again. Think harder. We are the students. We should be grateful for the lesson, even if the lesson is that we are failing the class. The paradox is a mirror. It reflects our desire for control. We want to control the narrative of the universe. We want to say we solved it. The star says, no, you didn't. It denies us the satisfaction of closure. It keeps the wound open. That is good. Open wounds compel attention. They force us to keep working. They prevent complacency. The star is saving us from the death of curiosity. The cosmic perspective. From 190 light-years away, the Earth is invisible. The Sun is a faint dot. From the perspective of HD 140,283, we are nothing. We are a momentary fluctuation of carbon on a wet rock. Why should the universe obey the laws discovered by the carbon fluctuation? It shouldn't. It doesn't. We are imposing our laws on the king. The king ignores the peasants' laws. The star is royalty. We are the peasants. The question, how old is the universe? We used to say 13.8 billion. Now we whisper it. We add asterisks. We add footnotes. Subject to the Hubble tension. Subject to the Methuselah anomaly. The certainty is gone. The footnotes are taking over the page. The star is the biggest footnote. It is the asterisk that ate the title. The answer. The answer might be that age is a human construct. The universe measures events, not years. The star has experienced more events. It is older in experience, even if the calendar is the same. Relativistic time dilation. Gravitational redshift. The universe is a fluid manifold of events. We are trying to map it to a rigid grid of seconds. The map fails. The territory remains. The darkness. We started with the darkness. We end with the darkness. The star will eventually go dark. It will become a black dwarf. It will disappear into the void. But until then, it serves as a lighthouse. A lighthouse warning us of the rocks of ignorance. We are sailing the ship of science towards it. We might crash, but we have to try. The resolution. There is no resolution in this video. There is only the mystery. I cannot tell you the star is 13 billion years old. I cannot tell you the universe is 15 billion. I can only tell you that they don't match. And that mismatch is the most exciting thing in the world. It means there is more to discover. It means the book isn't finished. Reality is scarier than fiction. Fiction has to make sense. The Methuselah star does not. Fiction has to follow a timeline. The star does not. Reality is the ultimate horror author. It writes plot twists that break the logic of the world, and it leaves us to deal with the fallout. So, next time you look up at the night sky, look for Libra. You won't see it with your eyes, but know it is there, the impossible star, the paradox in the dark, the glitch in the matrix. It is watching you. It has been watching for 14.5 billion years, and it is waiting for you to catch up. The universe is vast, old and dark. We are small, young and bright. We burn fast. The Methuselah star burns slow. It wins the race, but in our brief flash of light, we have seen it. We have named it. We have questioned it. That is our victory. We looked the impossible in the eye and asked, why? The investigation continues. The data streams in. The scientists argue. The star shines. And the silence of the cosmos deepens. We are alone with the mystery. And that is exactly where we belong.